Welcome everyone. I am the Director of Technical Architecture at IQ Solutions. Today I'm going to be talking about Drupal hosted on Kubernetes. This is kind of an introductory session, introducing you to Kubernetes if you haven't already gotten on that bandwagon, and how you could use it to host Drupal. Also, before we get into Kubernetes, I just wanted to give a brief introduction about containers as well. So let's get started with that. If you have some time, I'm going to do a very brief demo as well at the end of the session. Just a quick introduction about IQ Solutions. We're a health communication company based in the DC area, and we provide a whole gamut of services in the communication arena, right from social media, digital strategy, content strategy, obviously mobile, website, and application development, and a host of other features, services. And these are some of our clients. And with that, I'm just going to get started with our discussion for today. So before I just jump into Kubernetes, I wanted to talk about like traditional deployment. You've probably seen this before in other presentations, but what is the role of the container in today's kind of environment? A traditional deployment, we've had that for years, where you log into a bare metal server, you have an operating system, the hardware, and then you're installing apps out there. And obviously this became cumbersome and expensive. So we came up with the virtualized environment, which has been a very popular model. And in that model, you have virtual machines. You're dividing this environment into virtual machines, and you're trying to install apps out there. But again, it's not as efficient enough, because you see each of these virtual machines has its own operating system out there, and a lot of underutilized resources in that sense. And so here we are now with container technology, where we're kind of cutting out the virtual machine and just building these containers and separating these apps into single service containers and microservices. And this is kind of the world we live in now, which is kind of everything is built as a container. This is what it would look like in a microservices architecture. It's standardized now. We have Docker and other container runtimes out there, and makes it highly repeatable. Gives you all the isolation you want. It's very portable, so I can take these containers and run it on a local environment in a staging environment across different operating systems. And we're running it with a lot more efficiency, with a lot more resource utilization efficiency out there. So these are some of the benefits, and we kind of now build our in a previous architecture that we saw, you'd have a lot of things kind of mixed onto the one single server, which is a problem. So I just wanted to also mention the Docker container runtime. It's not the only one around, but it is definitely the most popular one. And for our examples out here, we're going to be just talking about that. There are others out there that are the cloud native, Cloud Foundation is kind of, you can find out more about them if you want to use them. But I think Docker has become the standard going forward. So we'll just talk about that. So, let's talk about, traditionally what we did is if you had to deploy code, or we wanted to make a change to a library that we were using, or modify, the Apache configuration, or make a change to the PHP configuration, we'd log into the server or a VM directly and make those changes. And even on every code deployment, we would go, either we'd have some kind of continuous deployment process that would copy the code over, and you'd have multiple servers where you would do this. With the container approach, you probably heard this term immutable. Every time you make a change is you build a brand new image. So everything is burnt onto the image and tagged with the new version, and then pushed onto a container registry. So that is kind of the container lifecycle model. So it's something, before you even get into the whole Kubernetes space, this is kind of one of those things you need to, in your organization, get some sort of a process like this in place, automated or not. So speaking of container, the container lifecycle, I just also wanted to briefly mention about container registry. So you'd also need a container registry, a secure container registry. And so developers, when they build these container images, they would push it up to a container registry. A lot of the big cloud providers, over here, we're talking about Azure, but GCP, AWS, all of them provide container registries, and they're fast and highly available. Some of these cloud providers also add a lot of value adds on these container registries. So now, instead of scanning on your actual server, they can scan your container registry and tell you if any vulnerabilities exist. So that's kind of another value add of these container registries. But now that you have a container registry and you have your containers built, that's when we really start talking about Kubernetes comes in place. And just really going back quickly on a typical architecture, what you would have to do is you'd have a load balancer, you'd have 3 Drupal web servers, you're load balancing across, you'd probably have a Memcache, a MySQL, a SOLR. You might even have Memcache on every of those web servers, which, that's a possibility. So you'd have to configure networking, create route tables, do the load balancing, install the software, configure it, install the databases, caches, and all the other things. And obviously that's not about it. You'd have to also just go maintain these servers, update all of them. This is kind of our typical architecture. So what is Kubernetes? Now, we talked about, that was kind of like an introduction into this whole, why do we need something like Kubernetes? And, we build these containers, and now there's got to be a way to orchestrate these containers and just get, we looked at the last slide, we got to do everything that last slide was doing in Kubernetes. And it's a lot of those manual processes are kind of automated in Kubernetes, managing and scaling these containerized applications, making the networking work. And the great thing about this platform now is everything can be, it's all about automation, and everything is about configuration. So everything is stored in a configuration, making it super easy to source control, manage, automate in a CI/CD system. So that also if you're just brand new to Kubernetes, what a lot of folks ask, why is it Kubernetes? And it's the Greek word for captain, and everything around this is like around the whole maritime kind of concept. And as we go along this presentation, I'll keep touching on that. Briefly, Kubernetes provides you service discovery and load balancing. We need hard disks. We need to mount storage onto these containers, so it helps with storage orchestration. It helps with the rollouts and rollbacks. If in a traditional deployment, we would have to either take a server out of a loop or do changes after business hours, or do things. We want to keep the application up and running. So some of those things can get much easier to manage with Kubernetes. Automated bin packing. So Kubernetes will assign CPU and memory to each container, and basically it does the allocation for you, and you have the knobs and levers to kind of control how much of that will be allocated. It provides some self-healing functionality. If a container is unhealthy, it'll probably, if there's a memory leak of some sort, it'll probably restart that container. It's not obviously going to fix that container. You still have to take care of that, but it might buy you some time. And we'll talk about some of the self-healing as we go along. And also secrets and configuration management. You're going to have keys, your credentials for your certificates, your private keys, your logins to the database. All of those are have to be managed someplace in a secure way, and it provides you the ability to manage those secrets and configurations. A typical Kubernetes cluster, this is what it really looks like, is on the left-hand side, what you see is the control plane, also called the master. And Kubernetes stores everything in this database called etcd. And it has everything around Kubernetes is kind of like API based. So it's all central to this API server. And these are some of the components of a Kubernetes cluster. On the right-hand side, you see the nodes. Those are the workers. So if you go by Kubernetes as a managed service with one of the three big providers, or even Linode or DigitalOcean. What they give you is the control plane, and you specify how many nodes you want, and they'll provision that for you. One other way of looking at this is Kubernetes is kind of like one giant computer. So if you're buying 3 nodes with 8 GB each, you're getting 24 gigs, and we have 4 processors that makes it 12 processors, and then that's your whole your compute cloud available to you, and so it's kind of aggregated into one big number like that, and Kubernetes will manage it. Will manage all the resources. It looks as a one unit. So with that, how do you manage a Kubernetes cluster? Everything is like API centric in Kubernetes. There are lots of tools around this ecosystem that are coming up. You have Visual Studio Code as well. They have an extension to talk to this API server, but traditionally the way to do it is with kubectl. It's the kube control. It's a command line interface that you install, and then you define all these YAML files of what you want Kubernetes to do for you, and you push through. You apply these YAML files to this Kubernetes cluster, and it will deploy the pods and everything else to do the scheduling for you. Kubelet is the scheduler that talks with this API server. And so these are the worker nodes. It'll decide where a pod should go, whatever your specification you provided. So you use the kubectl tool. We'll see some of that in the demo. And I wanted to talk about namespaces. So we talked about this one big giant computer. So you may get a 6-node cluster, and let's say this is not production, but this is your staging, QA, and development. You definitely want to kind of split it up in a way, isolate that, so that each of those environments is very clearly isolated. So namespaces is the way you would do it in Kubernetes, the use case out here is for development, staging, and production. You can also set up access and resource limits for each namespace using a resource quota object. So you may give development only so much CPU and so much memory, whereas you'd give the other environments a little more. And I have an example out here of a kubectl command. I'm just trying to find out all the pods that exist in all the namespaces. In this cluster, I only have this is basically the kube system, which is what Kubernetes, when it gets installed, these are the components it installs. We saw that diagram earlier on. You can see this core DNS, there's etcd, it's got the API server, the control manager, proxy, the scheduler, and the storage provisioner. So those are the things we're going to talk a little bit more about, and we have a dashboard as well. We would kind of split up our, like, let's say we had a client, the client name -stage could be one methodology that you choose to do of defining a namespace, and within that namespace you'd have your Redis, your SOLR, your MySQL, your Drupal, everything out there, and you'd have an ingress bringing traffic into this namespace. So namespaces are a way to divide your Kubernetes cluster into isolated spaces. Nodes we talked about, these are the compute instances for the cluster, and I have a Kubernetes command at the bottom. I have an alias set up, and so it just says kubectl get nodes, and I want wide, and you can see these are underneath. Kubernetes has these Ubuntu machines, and the Docker container runtime, and the kernel version, and all. I can see all of that. I'm never going to be able to log into this. It's completely managed by Kubernetes itself. Obviously, you could choose to do this on-premise, but there would be a different kind of undertaking. A lot of my examples out here are going to be like, you'd have a cloud provider to kind of deploy, to buy the Kubernetes managed service. So nodes are the workers. So let's talk about pods now. We've been talking about containers, and now in the Kubernetes world, suddenly a Docker container becomes a pod. And basically, pod is the way a container is represented in Kubernetes, and its storage in Kubernetes. So you can have a single container, or you could have some sidecar containers within a pod. And going forward, we're just going to reference containers as pods. So sidecars are essentially, you could have another process running, another container running in your pod, that is probably doing some sort of monitoring or doing some sort of log analysis or log shipping. It's not a very, it just depends on the use case. I don't think you would need to worry about this depending on what you're trying to do. But generally, pods are like one container in one pod is probably the most common use case. Let's talk about deployments. So we talked about kubectl and how you send YAML commands to Kubernetes. So this is deployment is also a kind of object in Kubernetes, and you can see the API version out here. This is across the board. You're going to see this. There are exactly 4 parts of a kubectl YAML file. There's an API version. There's a kind, and I'm saying deployment out here. I'm giving some metadata out here. I'm assigning some labels, and this is an Nginx deployment. And then I see a specification. So metadata and specification is what we provide, and status is another node that gets generated when you look at this deployment once it's in progress and you query it inside the Kubernetes cluster. It'll tell you, status will tell you exactly how this deployment is doing. It's got all the other information that etcd manages, Kubernetes manages about this deployment. So we would assign this metadata, and then the spec is the important part. As we would tell Kubernetes, if we want this deployment to have 2 replicas, and we would assign again metadata around that. And the specification here, I'm trying to run Nginx out here, and I want to use the public Nginx version 1.16, and I want to expose the container port 8080. So this is basically, once I do this and I submit this, I'm gonna have containers for Nginx running, 2 of them on Kubernetes once I submit this. Again, you would have you would build your own containers for Drupal. Or any other, SOLR, Elastic, whatever you need. These are the kubectl commands you would use to kind of get this. You could just say apply -f. Either it could be a URL or a file store on your system. You probably have these all stored in your computer, which is kind of through and source control this, because all these deployment files actually will constitute making up your entire system. If you want to describe the deployment, you would do describe deployment. You could also query the pods that this deployment is going to implement by using a label, and you can delete the deployment. So in essence, a deployment manages a replica set. Replica sets manage pods. This is kind of like the app, the layers as we go down. And a pod is an abstraction of a container. So I hope that's clear. These are some other kubectl commands you can do. You can change the deployment by just setting the image version. You can look at the rollout history. You can undo a deployment. You can roll it to a certain revision. You can just restart a deployment. And so these are all the rollout commands out here. And then at the bottom we have scale. So if I wanted to change the replicas, if I we saw like we had 3 web servers out there, and in the Kubernetes world, it would be 3 pods. But if you wanted to change it to 5 pods, we would just change the number of replicas. And so you could have 5 containers of Drupal running by changing the replica count. This is how you would scale and update deployments. This is some other kind of deployment files that I just wanted to show. So let's say if you were implementing Elasticsearch in a single node kind of deployment, this is kind of an example. I'm using the public Docker, the public Elasticsearch container. I'm using version 7.71, and I wanted to, and these are some environment variables I'm passing on to it, and I want the container port. This Elasticsearch is going to serve up on 9200. For Memcache, I would have another container. And again, I'm using this is the Google Memcache official image, and I'm exposing the port. And so I think what we've seen in this space is like there's a lot, just like how in GitHub you have public, public repos out there, and in the open source world, we've seen that there's a lot of collaboration And this is very similar in, you have Docker Hub, where there's an official image for pretty much everything out there, right? So it's a great place to go check out and start learning about how some of these things are done. The Docker file is there. All the versions are that are supported by them, and these are like official. So the MySQL container would be managed by Oracle, and they have all the experts who know about that technology, and so it's a great way to go learn things about that. And these public repos kind of really give you a lot of insight of how things are done. So now we talked about pods, but again, now we also do need to network this and make it a service. So we have 3 pods out here, and we have a service. So services are basically used to logically group a set of pods together and provide the network connectivity. And it can be if you don't want to expose it, you could have a cluster IP. Load balancer is typically what we use. And what that would do is expose the service, and cluster IP would just keep it within the cluster. The API version, again, the kind, the metadata, the spec, very, very similar methodology being followed across the board. And every time you declare an object, it's the type of object. Here it is, service. And you could also have services pointing to things that are not actually stored in Kubernetes. These could be external to Kubernetes. So let's say you had a MySQL sitting somewhere else. You can think of an external name as like a CNAME pointer. So it's a way to define services that don't sit in the cluster. This is how a service gets mapped onto a deployment. So I'm going to tell this service, hey, listen to target port 8080 and make it available on port 80. But the selector you need to look at, so it's going to go find all the pods with the selector app nginx. With the match label is going to be nginx, and it's going to, so when I change this deployment to, let's say, 10 pods, this service will now load balance 10 pods. Right now it's load balancing 3 pods, but so it's as easy as that to kind of start scaling these services up and down. So that's how services are mapped. Another concept I just want to throw out there is the Ingress Controller, because the first thing when you do is when you start up a Kubernetes cluster, whichever provider you're with, to bring traffic into your Kubernetes cluster, you're going to have to define launch an Ingress Controller. And it provides, these Ingress Controllers are kind of, nginx one is the most common out there, but there are others out there. You'd have to look at your cloud provider to see but they have very tight integration with the web application firewalls and the the firewalls with AWS, Azure, GCP. It's a single entry point into your cluster. It provides you SSL termination if you wanted that. So it really, what this really does is I can have multiple domains I'm serving up through a single ingress, and I can have different bots within that being routed to a different service. So it really lowers your cost for, you don't have to have multiple external IPs being exposed to the world. And you could also have this within a VPC or VNet, and then use some other kind of another kind of firewall product that actually talks to the ingress. And again, everything out here is managed by a configuration. So I have, again, this is the kind of file that I have is called ingress out here. And I have 2 hosts out here, and they're both pointing to different services on port 80. So I could have 2 different, with one ingress, I could have 2 different Drupal instances out here that are being served up, and without having to have multiple external IP addresses, all controlled by the host name. And you would also have your certificates and all the SSL termination in here if that's what you wanted. So let's talk about obviously we've talked about if we were doing we're hosting a Drupal site, we do want persistent volumes. Persistent volumes are going to be used for obviously for your SQL, but also for static files that Drupal saves. So the way to implement that is through a persistent volume. Persistent volume is defined. You would define what storage class you need. The storage is going to persist across all the clusters, across the cluster, and will be available to all the nodes. And if the pod goes down or recycles, this data is always going to be available, so it's persistent. So storage classes, there are different kinds of storage classes, object or file storage, and this is what we would need if you were saving static files in the site files directory for Drupal. This is known as object or file storage, and then for disk you would use block storage, which is much more low latency. The thing about block storage is that you cannot have rewrite many. It only writes to one. You can only write to one disk. Storage is not namespaced. It can be available to the entire cluster. And pods access volumes using claims, PVCs, persistent volume claims. This is a definition of a persistent volume. I'm defining the capacity I want, and the storage class is specified out here. And there's a secret that is, we'll talk about secrets right now. And I want the access mode to be read write many. So this is kind of another way of showing this is your cloud provider will provide you different storage classes, and you can even build your own custom storage classes. But a volume claim will say, I want, do I want file storage or do I want a disk storage? And that'll define, whether you want a persistent volume or of a certain type. But this can also be automated depending on storage classes. So it'll automatically generate the persistent volume. Generally, what you want is for single pod access, like a MySQL or a SOLR. You cannot have you can have multiple pods writing into the same disk. You'd want file storage for that. And this is a very good use case for us, where we store files, static files in Drupal, and multiple pods will need to access it. There are other, it depends with different cloud providers. Recently, AWS announced EFS, which is basically kind of providing this sort of storage, is a recent announcement. Prior to that, folks were using, direct access to, because you want concurrent access to this folder using S3FS or Fly System or something, one of those modules in Drupal, and accessing file storage for our static files. So a pod being mapped, we have a volume claim out here, and this volume claim is gonna get mounted to a certain path. So in this case, I'm mounting this volume claim to site's default files. This is where I'm going to store all my static files. This is how you would specify it in your, again, the kind is persistent volume claim. And then this is within my pod itself, in my deployment definition, that I'm mounting the volume. So configuration maps is another object type in Kubernetes, and you'll see it used pretty often. They're basically abstractions for volumes, but it's a way to manage configuration. And it's super fast. It's basically stored in the etcd database, and it allows you to easily update configuration without changing your container. And so things like your MySQL configuration or your Nginx deployment configuration would be stored in this. You don't want to keep redeploying those. If you change the configuration map or you change a setting, Kubernetes will automatically recognize this and kind of restart that deployment. Secrets. So let's talk about secrets. So this is another Kubernetes object type, and again, you would use this to store your MySQL database password, username, any keys that have to be stored. You would base 64 encode that, and then apply it via kubectl. You would store this. Once it's set and put inside your cluster, it is not going to be visible to anybody. So that's the reason we have. This is a mechanism that Kubernetes uses to keep everything contained within the cluster, and as folks come and access it, they're not able to see the real values. I wanted to introduce the stateful set object. I think it's probably kind of a little bit out of the scope of like an introductory kind of discussion, but stateful sets are used for databases like MySQL. If you wanted to have Elastic or SOLR in a zookeeper format where you have a clustering situation, this stateful sets are the next version of, it's sort of a deployment, but it has a unique ID to each pod name, because what happens is something like, I'm just going to use this next slide to explain this. When we say stateless applications, and Drupal, is a great candidate for that, because everything is stored in the database, and the file system is also shared. So any kind of state is never stored in the container. It's always, but something like MySQL does need its own dedicated disk for reading and writing. You can only have one master. So they follow a master-slave kind of methodology, where MySQL pod 0 will always be the writer and read, all the other pods are going to be like the slaves, and they're just like data replicas. This is a much harder thing to manage when state is involved. So you have to know a lot more about how things work in here. You'd probably use a chart that we'll talk about in the next slide to manage this. So that's stateful sets. You could, I did show deployments for Elastic in Memcache, and you can do the same with SOLR. Those are things that you can actually do in a single pod and actually vertically scale it. Databases are hard to scale horizontally. It's more vertical scaling. And daemon sets, I just want to, is another type of object. I don't think I'm going to spend too much time on this, but it's basically a way that all your monitoring and Kubernetes in itself and kube system does install a few daemon sets. What this really means is you define a definition, and Kubernetes will make sure that a part of that definition is running on each and every node. And so every node has one of these. So, coming back to our discussion, database must be persistent. We looked at that. Drupal file directories must be persistent and shared among web containers. The CSS and JS aggregation that needs to be persist into certain directories, again, would be shared in this file, static file directory. And then the next thing is, how do we get our settings and configuration onto the deployments, and how do we run cron jobs? So in our settings page, we would be, we'd have all the environment variables set up out here for Drupal. And in the deployment file, we would specify the values, and each one of these deployments, for each, let's say you had a staging environment, a QA, things could vary, and you would store that all in source control, and the deployment files would be there. So, once you construct a complete deployment for with the service and an ingress and everything for, let's say, dev, it's all about just changing values in a YAML file and reapplying them, and then you have a brand new environment out there. So you can see a lot of those benefits. You get right away with something like this. Everything is completely stored in configuration. You're never gonna have to log into a server and do any of this, or change any of the environment variables, or change any of the setting files. So it becomes super easy to manage this, even if you're just doing it, in dev and QA. And we run some of our sites in production, and we this is a great way of doing things. So you can see out here in my deployment YAML file, I have my database password and my and the DB user. These are basically these are secrets. You can't see it, and but everything else you can see out here. I've got the Redis host. I've got the DB port, base URL, things that are not the recapture site key. And if I was doing some geocoding, I could store those as secrets too, or just specify the values right here. So, going back to stateful sets and databases, we've found that, you can do MySQL within, you can run it in a Kubernetes cluster. It just depends on your level of proficiency of how much you want to take on and manage. But in a production environment, we tend to use RDS, Azure MySQL, or the GCP MySQL that's provided. It's just a more robust option, especially if you're managing customers' data in production. You really want to be, if you're going to do that MySQL in a stateful way, this is probably the better way to do it. It's probably more highly optimized by a cloud provider. And there are options for read replicas, and it's probably might even turn out to be a little more cost effective. It just depends. And then again, you would use a Kubernetes service to point to this external service declaration. Or you could go directly to that, the RDS or MySQL instance in Azure MySQL instance by specifying it in your deployment environment variable. And then, to maintain, the Drupal cron heartbeat, you can have Kubernetes provides you a cron job object type. So it's like a cron job is essentially, it's like a one line of a cron tab file, each one of these YAML files, and you can specify the schedule, and you'd have a container with the CLI tools installed. So you run your drush cron, or if you want to just go to cron PHP directly, whatever you could specify it here in that. And these are some of the local development environments. So even when you get into this whole thing of working with Kubernetes, we've kind of also converted all our local development environments using Docker Compose and Lando. Everybody's kind of in that container mindset of working with how things are done, and the goal is to contain everything into a stateless container image as possible, so you can scale and deploy it and kind of have a container workflow within your organization. So I want to check how we're doing with time. Okay. Yeah, so your continuous deployment process would be you'd have base Docker images for PHP and Drupal, and then you would just copy copy your code over into these containers, and then push them up into your registry, and you can get a lot of automation in your continuous deployment pipeline. So a Jenkins build would look something like this. We have we do all the Docker building, and when we log into our container registry, we build a web image with the latest branch. The Docker file will specify where the code has to be copied into. We have the base Docker image that I just showed you. You would log into your container registry, push up the image, and then you can use Ctl Commands in your deployment to kind of make sure you're pointing to the right Kubernetes cluster in the right namespace, and then you can just set the image deployment to the latest one. So relatively easy to kind of automate. And then you could also have lifecycle events. They're out of scope of discussion, but even if you're using HELM or using just plain kubectl, there are all these lifecycle events. So you can do your drush update DB, configuration import, cache clear. Of course, if you're doing this in production and you're doing update DB, you also have to have you should have your database backed up and all of that. So it's not going to be as Drupal manages state in the database. If you're going to update the database, then rolling back is not. You want to have take all the necessary precautions that you need to bring your database back to the state it needs to be in if you're going to go back to your previous container. And also through keeps, we have a lot of, you have all the kinds of knobs and levers you need to manage requests and limits for resources. So this is a good idea to have this on some of your deployments, because if you let it go without any of these request and memory limits, they could be a process. They could be maybe your Elasticsearch goes and starts taking up 3 CPUs and takes up a lot more memory, and then it will cause a problem for all your other parts to go in a pending state and not get scheduled. And so it's hard to it would be hard to kind of debug a situation like that. So it's a good idea to kind of to use requests and limits. Request is basically the minimum amount required. So I want 250 milli CPU out here, and I want 64 meg memory. That's my minimum I need. And if Kubernetes has that, it's going to go schedule this pod. And you have a limit out here. If I say if this pod is requesting, if it's going over 500 milli CPU, then you want to put some CPU pressure on it. If it is actually going above 128 meg, the limit that is set out there, this is actually going to evict the pod. It's gonna go in an evicted state It's easy to evict pods with, there's nothing, you can't put any kind of memory pressure, so they get evicted. Whereas CPU, Kubernetes has some control of giving you a certain amount of millicores. I also wanted to kind of quickly introduce any discussion about Kubernetes is HELM. It's basically a package manager for Kubernetes. It's like, think of it as like the Yum apt or the other package managers that exist. It's a great way to package YAML files and distribute them in public and private repos. And it's a great way to learn, actually. I mean, I go look at some of these Helm charts just to see how things are done, and it's a great way to learn. Very easy to spin things up and down. I want pretty much everything out there. There's probably a Helm chart. Any kind of software that you want to run, there's going to be a Helm chart available for it. So this is a Helm chart, just like this is a open source Bitnami Drupal Helm chart out there. I just wanted to show this, everything that we saw out here is kind of defined in, you have a requirements YAML, which is going to give you, this needs MySQL to run. So that's going to be, that's one of the dependencies. It's going to be specified in the requirements, and also in the chart YAML, which is kind of will give all the basics about how this chart is built. And then they have values YAML, which is basically all the overrides that you can do. But if you go look at the template directory, it has this Helm chart is going to go in how a deployment should be done, how a persistent volume should be defined, persistent volume claim, how the ingress should be defined, the secrets, the service, any secret TLS, SSL that you're doing. It's all stored in these template files. So it's you can pretty much you can get a Drupal running up in a couple of command line instructions with overriding the values YAML file and specifying what you need. So it's a great way for packaging and templating applications. We tend to use a lot more of kubectl just because we are kind of just more comfortable and we want that control. But you can build your own Helm chart for your own, and it's highly, highly repeatable. But it's also just a great way to try new things out. And so, as I mentioned, it's a templating engine. If you were defining your own template, you would have a values YAML file, and that would actually translate the values from there into whatever container image. And I'm probably going to just show a quick example of the values file. Use cases for Helm, definitely you're going to have to install it for, if you're doing something like Nginx Ingress, the first thing that your cloud provider is going to make you do is launch an Ingress, and you're probably going to, and they're going to give you Helm instructions to do that. And then for stateful sets and daemon sets, things that require a lot more knowledge about persistence and operators, and there are recipes out there, just to get this up and running. Again, this is like, if I was wanting to run the Helm chart for Drupal, I would go add the repo, the Bitnami repo to my Helm repository list, and then I would just go install my release. And I would, in the values YAML file at the bottom, I would just do the overrides. Here it's being done all in the command line. But if I wanted to modify the database username, password, excuse me, I'm just gonna, specify these values in the values YAML file. So in a summary, I just wanted to kind of, Kubernetes, while it also gives you all this orchestration flexibility, it also gives you a lot of portability to move across clouds. You do have your container networking, the networking and storage that is different among these cloud providers. They all do different kind of storage classes and different options that you'd have to look at. But overall, once you have your application, in a state like this that is running on Kubernetes, it offers you, you can move it across any way you want to. It gives you a lot of that portability. You're not tied to that one cloud provider. It definitely gives you better utilization of your compute cluster. So let's say we had dev staging and production, you probably won't have production on the same cluster, but you could give, fewer resources to dev. You could even take down your dev or staging if you wanted to. If you wanted to get do something else on a compute cluster for a while and then bring it back up. A topic I didn't touch upon is Kubernetes is it's not just Drupal and PHP. It's like, if you had some decoupled sites and you wanted to do some Node.js in there, or you had some Java applications, SOLR and Elastic, of course, they're all Java apps. But if you had anything else in your kind of environment, it's a great way to isolate it and kind of run it in a container and orchestrate it with Kubernetes. It's super easy to stand up environments and upgrade them as needed, and it's all automation friendly. Everything can be scripted to a point, and right from deployments to how things are managed. So these are some links that I thought if you're getting started out with Kubernetes, this one link of State of Managed Kubernetes in 2020. It basically gives you an in-depth analysis. I'll share these slides as we're done out here, and then gives you kind of a comparison of providers. But this is, again, these things change so rapidly. So you definitely want to look at the documentation that your cloud provider has and what new things they've introduced. As I was mentioning, EFS and the file storage kind of they specifically have something now for Drupal, WordPress, and all of that. So what storage class you should use if you wanted to go down that route and not the S3 route. So I think with that, I was gonna do a quick demo. Do we have time for?
Hi. So we've got people have lunch. So maybe we could do some of the questions and then do a demo. I don't know. What do people want to do? Do people want to do questions? If so, say yes on the Zoom, maybe the little icon. I don't see any yeses. So
there are questions in the chat.
Yes, I see the questions. Absolutely. Thank you. So let's do the questions real quick in case people need to get going. All right, so the first question I saw was on the channel in Slack from Chris K. He asked, for hosting multiple different Drupal sites, should each site have its own Kubernetes cluster or K8s cluster, or is there an advantage to running multiple sites in one cluster with the appropriate ingress routing?
I think that's the whole. I think it's better to do it in one cluster. Now, the one thing I would say about that is, Kubernetes also has versions that it maintains. So if you had a prod cluster, that's the only place I would keep things different, because you don't want to upgrade your production cluster without having done it before in dev and QA. So that we generally keep that cluster separate from the production cluster. But it would make it would be a lot better to do it all in one cluster if you had multiple sites. That answers the question. Yeah.
Okay, and we have another question here. Why not use a pre-made solution like Acquia, Pantheon, Platform SH, etc.? What are the benefits of doing it yourself?
Yeah, So exactly. That's a great question. Yeah, you could definitely use Acquia if you're just doing Drupal, and it's a completely managed service, and definitely it works well. I think if you had multiple sites that you were hosting, and you would definitely see some advantages in terms of cost, and also the other thing about sorry, I lost my train of thought out there, but yeah, you would definitely see advantages in cost. But if you had other kind of workloads out there, so let's say you had some kind of a decoupled site out there and some other things, or a static, that's when you have different workloads. It's a good way to mix and match those things with one sort of system. Yep.
Okay. Two more questions that I have logged here. Let's see. A question around the setup. If there are no changes in infrastructure / configuration, but changes only in the Drupal code, then does it rebuild the entire infrastructure or just update the Drupal Docker image and then rerun the associated services? If you want to read these questions, they're in the chat.
Right. Okay. Yeah, I see that question. Yes. Yeah. So in that case, if there's only a change in the Drupal code, then you would only rebuild the, you would only build the, the Drupal image again. And, with the, that we saw, you would just, and then you would just update that deployment. And, that's all that's going to be needed. You don't have to rebuild the entire infrastructure. Yep.
Okay, the last question is why use Bitnami? And then after that, if anyone wants to raise their hand to unmute to ask verbal questions, why use Bitnami?
Yeah, so I think that this is only for an example. We've kind of done our own custom we use that as a way to look at what other folks are doing with different kind of container builds and what are the best practices out there. But I don't think I'm not recommending or kind of saying Bitnami is the way to do it. But there's a lot of resources out there for you to go check out, and you would to get to your perfect environment.
Go ahead, Salim.
Yeah, how many sites? I take it you've set up sites and you're hosting and managing sites for your customers. And how many sites are you hosting and managing?
We've quite a few actually. Quite a few, in production we've got a bunch, and then obviously we've also in our development and QA and all of that, we've completely gotten rid of all the virtual machines we had and trying to do all through Kubernetes. So
are they in like tens or hundreds or
tens or hundreds? Not hundreds, but I would say 20s or 30s maybe. Yeah.
Any other questions?
Would love to see the demo.
Okay.
Yeah,
sure.
anyone that wants to stick around now that we've got through the questions, he can go ahead with the demo and thanks. Yeah, go ahead.
Sure. So yeah, do you guys see my screen?
Yep.
Okay, let me just make sure.
Can you make the font a little bigger, please?
Sure. Let me see what I can do out here. How's that?
Yeah, better. Thank you.
Okay, awesome. I'm just going to close the chat window out here. So yeah, I wanted to just show, there was a question. I use Bitnami out here. It's one of those easy ways to get a site up for running in a demo environment. But I just wanted to show a couple of. So right now I have. So I'm going to do a couple of Ctl commands and. So here I have my Ingress Controller running. I have a Drupal govcon and welcome, which is just basically an image out there that that would look like something like this. It's basically a test. So here I have my container just rendering this, and this is. If I wanted to go ahead, I'm just going to look at the welcome YAML file. I'm running a container out here and I'm passing one environment variable out there. If I wanted to change this environment variable or change the image that I'm using, all I would do is modify my YAML file. And then I would just go ahead and I would go kubectl, apply. And it's actually terminating that one container out there and now running the new one. So I have a new deployment in place. And I just changed the environment variable and it's running the machine with the new container with the new environment variable. another, so you can see how quickly I did that. Right now we're running we're just using one pod out here, but if I wanted to scale this, let me go into, let's say I wanted to change the number of pods, I wanted to scale it up, I would just issue this command, and then I would say, and you can say it's actually fired up 10 of those pods now. And if you wanted to go look at I'm just going to do a kubectl. So we have a service out here, and I'm just going to describe I'm describing the service out here, and you can see the endpoints I have now. It's load balancing between 10 of those pods, and so it's highly flexible if you had to change things, and kind of scale things up. Everything is stored in configurations. All of this would be stored in my source control. The current state of my cluster for each of my environments, everything can be easily managed. So it's just like, makes it really easy. I wanted to show you this values YAML file. This is like the Bitnami HELM deployment that we just saw out there. And I wanted to just use the 906 version of Drupal. I applied that and ran it. And I just want to try it out. So these value YAML files will actually override some of the settings and be used in that template that we saw. It'll get replaced, and I go back out here and I go. This is the site that I just launched. This was just only for the demo, and I'm using 906. But you could take something like this. It's a great place to start and get going and see how these you can make a copy of that chart and just kind of work it up to what you need it to be. So. I just wanted to, obviously this is very introductory kind of commands out here. If you're familiar with the system, this is, these are some of the commands, you could look at the ingresses, we could look at the services, deployments, we can roll things up. This was the command that I used to actually fire up with my own values that I wanted. I could hop into the container by using exec, I could look at the logs. So with that, I think, that's all we had on the demo. Any other questions?
How
Okay.
are you managing? Sorry.
Go ahead.
How are you managing dev test live?
How are you managing? Sorry, I didn't get your question. Yeah.
Dev test live environments.
Yeah, so we have a namespace, and we have obviously we have a lot of it automated, in the sense that we have YAML files that are organized by those environments, and it's also in our Jenkins we have we've configured it as we change things in an environment, it gets automatically deployed to that environment. So we don't manually go start running these commands ourselves, but we kind of have an automation via Jenkins.
Okay, thanks.
Thank you. I guess with that, I would say, thanks for coming to the session. Hope you enjoy the rest of the conference.
Thank you. Yes. There's one more question if you have a chance.
Okay.
Kevin Holland asked, came in late, apologize. Does the solution allow for blue-green deployments?
Yeah, you could do that. I mean, definitely. I mean, you could have, two full environments, like, but I think Kubernetes also does give you other ways of, where you could achieve something like that. It's so easy. But if you wanted to, the answer is yes. Yeah.
Okay.
Yeah.
Well, thank you so much for presenting today. Thanks everyone for attending.